Yeah, hi all. Welcome you all to the monthly webinar session of Kubernetes Sri Lanka. So today we have Tanisha Banik, and she will take us through the journey of chaos to clarity in Kubernetes with Open Telemetry Collector. Today, before starting the session, I need to tell you some exciting news to you all. KCD Sri Lanka 2023 will happen on 9th of September at Trace Expert City, Colombo. Let me share our website. And, yeah, you all can visit KCD Sri Lanka 2023 website at kcdsrilanka.org link. Then you can register to the uh, event and buy a ticket. For that still we are in pre-sale period. That you can see the ticket price in the screen. So don't get late and grab your tickets now. So now we can move to the session. So Tanisha, screen is yours.
Yeah, thanks, Jared. Let's start sharing my screen. It's visible, right?
Yeah, you can see.
Okay. Can you confirm if you can see the slides?
Yeah, Tanisha, we can see them. Sorry.
Okay, thank you. So, hi everyone. I'm Tanisha and I'm a software engineer at Juniper Networks. Today, I'm going to talk about Open Telemetry Collector in specific and how it can be applied in Kubernetes. Also, how it brings, uh, as the title suggests, from chaos to clarity. So, moving on, this is a little bit about me. Uh, about you can connect with me on GitHub or LinkedIn from the links given. So, this is our agenda for today's session. Moving on. So, before starting with even Open Telemetry Collector, let's try to understand what is observability, right? So, as we know that we started with monolith architecture and then we gradually moved towards the microservices architecture where all the components in an application is being divided into different types of micro services which are distributed across different systems. Now, handling the microservice architecture in lower scale might be easier, but when it comes to larger scale orgs or business groups, at that time it becomes a bit difficult because you would have to know what your system is like thinking or what your system is, how your system is behaving and all. So you can't just understand that without observing your system or without monitoring your system. Now this is where observability comes into the play, right? So it's the ability to measure the internal states of your system by examining its external outputs. So you will be getting some data out of your system, which I will be talking about more in the below given metrics logs events. So basically, you will be using those data to understand that what is the current state of your system where all of your applications are running. So namely, you can observe them uh, via all these types of data, that is metrics, logs, events, tracing. Now, we should understand that what kind of data type is needed at what time, right? So to understand that, starting with metrics is, this is a kind of a high level aggregated data, which shows you the numerical performance of your system. It can be CPU, it can be memory, it can be network bytes, and so on. A log is a very detailed kind of, text record, which can be structured or unstructured, and it comes with very like granular amount of details as well as with the significant metadata, right? So it always gives you information about the activities going on in your system continuously. A event is more of like a very specific kind of data. It isn't that granular. It gives you information about specific endpoints or a specific information about your system at a particular moment of time. And it also signifies that let's say something happened, right? Let's say you establish connection with your database, then you might get a like a notification or even an event that yeah, this is something noteworthy that happened in your system. Coming to trace is essentially, it shows you the flow from one microservice to another microservice. So how is your microservice A calling microservice B? How is the flow going? How many requests? What is the time being taken? How much time is the request taking? What are the data sent? And all those flows are being showed by the trace. So being understanding that, let's move to observability trends. So I'd like to show some stats that I've gathered from the web. So the first point being, it shows that advanced observability deployment can cut down your cost by 90%, which is a huge number as you can see, keeping costs down to 2.5 million annually versus 23.8 billion for observability beginners. This was given by the Enterprise Strategy Group, which is basically a consulting firm in the year 2022. Second being, more than 70% of the respondents believe that unified observability. Now, unified observability means everything being observable, that is metrics, logs, traces, events, or any other kind of data. So if you combine all of them and visualize the observability, uh, it people believe that 70% of the respondents believe that it gives you the best experience for you as well as for your customers. Also, estimates from Honeycomb shows that observability cost could be up to 30% of the cloud bill. So, being considering that everyone is moving to cloud these days, you can see the amount of cost it would incur you if you know the observability is not handled properly. So, observability leaders report a 69% better MTTR, just mean time to resolution, for unplanned downtime or performance degradation, right? So, any kind of problem you're trying to solve or your engineers are trying to solve, it can be performing better with a 69% MTTR in case you have unplanned downtime or performance degradation. Coming to the last point, that is 43% of the organizations align observability. They think that observability should be a unified form of metrics, logs, event traces to collect and analyze your system, right? And so, coming to how critical is exactly observability? So, enterprises nowadays, small or big, they don't just have a uniform set of tools. You might be visualizing your data with Prometheus. You might be visualizing your traces with Jaeger, which is a distributed tracing system. You might be analyzing your logs using Loki, which is by Grafana. So, as you can see, these are a very diverse set of tools, right? And you just can't combine all of them under one umbrella. Otherwise, if you even if you were to, you would have to make a lot of changes in your system as well as the products, right? Second point, lots of integrations to be taken care of. As I just mentioned in the first point, you would have to integrate all of them together one umbrella so that they can be visualized in a uniform way. The ever growing data, as we know, it's the big data era. So the data is always growing. Uh, this can be also compounded by the challenge of inefficient data collectors. Data could be, streaming continuously throughout the day, but the data collectors have to be robust so that they can take the data or maybe buffer it somewhere or maybe send it to some other place, right? For that, you need your data collectors to be efficient. Otherwise, they would be consuming a huge amount of CPU, memory, or even network, which can in turn lead to higher infra cost in your cloud or even your on premises. So, last point being, organizations need deeper diagnostic data. So, just understanding your data doesn't help, right? You need to analyze your data, for which you need to understand what is the root cause of that problem. So, for that, you need proper observability to have that kind of root cause analysis. So, coming to OpenTelemetry collector. So, OpenTelemetry collector, I believe, this helps you in all these problems that we just saw. It's an open source observability framework. It's a CNCF project, and it helps you to instrument your application and deploy it everywhere. What this means is you just need to connect your application with OpenTelemetry collector. That's it. After that, you can just plug different external tools to it without any problem and deploy it everywhere. Intelligent and quick root cause analysis. Since you don't have to change your application more and more and more, so you can just go through one thing, that is the OpenTelemetry collector, and find out the root cause with all the debug information, all the debug logs, traces you need, right? And all the data is communicated by the standard OpenTelemetry protocol. That is again, which we were talking about, unified or uniform observability. Everything is done in the form of a protocol called OpenTelemetry protocol. Having a single agent for logs, metrics, and traces prevents vendor logging and saves organization time. So what this means is, let's say if you were using Prometheus or any other tool and you want to do some change, or let's say you want to call the APIs of those tools, right? You need to again depend on that particular product to make changes or to collect or to call that API from your application. What OpenTelemetry Collector does is it helps you to collect all the metrics, irrespective of which vendor it is, or traces or logs, right? So whenever you are like collecting data through OpenTelemetry Collector, you just need to debug or you just need to see what your individual external tools are doing. You don't need to go into in depth for any external tool, or you don't need to combine them or change them even, right? So also the traces, metrics, log, or even events, they are widespread among 11 programming languages. You can easily instrument it in your applications, including language like Python, Go, Rust, and so on. You can run your observability stack independent of the vendor dependencies, as I said. Doesn't matter what kind of external tool it is for observing your traces, metrics, or logs. Lastly, single set of APIs for observing any data in your application. So that is, it provides you a uniform set of APIs or tools. You don't need to depend on different kinds of tools to be plugged in your application. So yeah, now coming to the part where what are the benefits to Kubernetes with that? So as we know that Kubernetes has a lot of data points, always logs being streamed in the Kubernetes pods, nodes, right? So the OpenTelemetry collector acts as a central data collection in Kubernetes. You can also collect your logs from Kubernetes, the metrics or the traces. It's a vendor agnostic data export and import. Also, you can run the OpenTelemetry collector as a daemon set or as a stateful set or as a replica set, right? And you can also deploy it as a sidecar that can be with your container in the pod and aggregate and analyze logs from all the nodes or pods. So this shows that how easy and flexible it is in terms of deployment in Kubernetes. It can automatically capture logs or any kind of other data, traces, metrics from your application. You don't need to do any kind of extensive configuration. You just need to put it as a stateful set and point it to the particular endpoint or the service endpoint in Kubernetes. That's it. So coming to the architecture of OpenTelemetry collector. So as we can see on the left side, we have OTLP, Jaeger, Prometheus. These are all the external tools. You can also see here like Jaeger, Prometheus, or even Loki and any other tool. These are all the external tools that can be plugged in. On the left side, we can see receivers. So in OpenTelemetry collector pipeline, receivers are the first point of in the front line, you can say. They receive all the data. They act like a consumer, as to say, and they collect all the data from a particular tool, like let's say Prometheus. And in between, we can see processors. So processors are basically, if you need to do any kind of manipulation in your data, like patch it or filter it or add any kind of other attributes, that can be done with the help of processors. These are optional in the pipeline. You can put a processor or you cannot, or totally depending on your business requirement. Extensions are basically, they check whether your OpenTelemetry collector is able to collect the logs or traces or metrics or not, whether it's reachable from a particular endpoint or not. All these things are taken care of by the extensions. Again, these are optional. Coming to exporters, these are, you can see, ultimately where the data comes at the end of the pipeline. The exporter decide now where will the data come after all the consuming and all. So that is what the exporters do. The receiver and the exporters are the compulsory part in a pipeline. Processors and extensions are totally optional. Uh, just also one point, you can also connect your different OpenTelemetry pipelines using connectors. So just to show you, this is the way where you can have multiple OpenTelemetry pipelines. So let's say you have some OpenTelemetry pipeline running in your application cluster, some running in your edge cluster, and some running in your cloud. So you can collect all of them using a connector, right? Yeah, so coming to the demo currently, uh, so just to give you a context, the demo will include a distributed messaging system called NATS, which is a very powerful messaging system that is developed in Golang. Just to give you an overview. So NATS is a very powerful distributed broker system, just like Kafka or RabbitMQ, but it provides even more features compared to those. So we will be today looking at the NATS receiver. So NATS is receiver or exporter is not currently supported in the OpenTelemetry contrib repo. This repo basically contains all the external receiver or exporter you can have for your application. So in the receiver, we can see different receivers such like um, Cloudflare receiver or Datadog receiver or Docker Stats receiver. So similarly, we will be looking at something called NATS receiver, which will consume data from a NATS publisher or a NATS producer, right? And it will be a simple publish subscribe model just like Kafka. So this is not currently supported. So I've created a NATS receiver uh, where we will consume all the data in a particular subject. So in NATS, the topic which we call in Kafka is converted to subject in a NATS. So we will be publishing to a certain subject, and that will be consumed by the NATS receiver, and that will be exported in Thanos, which is again a very powerful Prometheus, observer monitoring tool. So this is a highly available Prometheus monitoring tool, as you can see. So we will visualize our metrics using nets, and we will be using the metrics pipeline to visualize the metrics. So coming to the pipeline, what we will go through, as you can see here, receivers is where we define a receiver that in our case will be the NATS. The brokers is the service endpoint of the NATS where it is running in Kubernetes. So to show you, I'm running my NATS here. So you can see the NATS running, and this is the service endpoint that I'm giving. So here we have the topic or subject. I have given the topic name as updates.new. This is another configuration in the NATS. Encoding basically means what kind of data you will receive, whether it will be a JSON, whether it will be a string or proto format or any other kind of format, right? So for now, I'm giving just a custom format. You can also define it as a numerical format as you wish. So yeah. And in the exporters, we have logging. So logging basically, it's a kind of exporter where it takes the data from the receiver and it just prints it to the screen. Prometheus Remote Write is the Thanos exporter, as you can see. So this is a Thanos that is running in my system. So here my Thanos is running. This is the receive router where basically I am sending my data to this endpoint 19291. And in the pipelines, we can see a metric pipeline. So you can have many pipelines like this, logs, or even traces like this, where you can define your all the exporters and receivers. But since I'm only going to see the metrics part, so in the receiver, I have mentioned the name of NATS, as you can see. In the exporters, I have given two basically exporters. It's an array of exporters, logging as well as Thanos. So let's move to the demo. So currently we don't have anything running in this namespace. So let me apply the manifest. So this config map is being referred to by this hotel deployment, which is a stateful set basically, and it's running with this image this, and it's exposing ports like OTLP ports of HTTP and gRPC. So gRPC port is 4317 and HTTP port is 4318 for OpenTelemetry collector. And this is the service that is exposing this stateful set. So now if we see, you can see that our OpenTelemetry collector is running, and we open another tab. So here we can see that the OpenTelemetry collector is running, and if we were to see the logs, so we can see that it has started, it is ready to receive metrics. So now, since my receiver is basically NATS, so I will exec here, and this is basically the NATS pod from where you can publish messages. So it has a CLI called NATS CLI. This is a CLI for NATS for publishing or sending any kind of message. So and I will be forwarding my panel so that we can visualize. So my Thanos is running here currently, and let's send a data, one data point to our NATS receiver. So this is the command for sending the data. So here we can see that NATS is the CLI, pub means publish, updates.new is the topic or the subject, and this is a JSON structure which I'm sending to the NATS queue, and it will be received by the NATS receiver, which is basically a consumer. Let me change the timestamp. And let's change the value to so this is basically any kind of resource name. So resource attributes are basically from where your data is originating, right? So let's say I'm originating some metrics from a node 1 with the timestamp at this point, and the metric attribute as, let's say, something related that is closely related to our metrics, right? The attributes related to our metric. So let's say it's a metric coming for a particular, let's say, uh, VM. So let's say VM1, and the value of that metric, let's say, is 70, right? So now let's publish this data. So we can see that data is published. Now if we go to our okay, let's change the timestamp a bit. So let's publish again. And let's change the timestamp. Yeah. So you can see here that data is being sent. You can see here the metric name is metric, let's say, the value being 80, and the metric attribute as VM1, as well as the resource attribute as node1. Now let's see what we can see in the Thanos, whether the data is being received in Thanos or not. So before going there, let me show. So the Thanos will identify a data as this, that is, a data will have an external label that is being set by Thanos, called cluster is Minikube, since I'm running a Minikube cluster. So let's see. So I will be searching a Thanos query here with the filter as cluster is Minikube. So as we can see here, metric cluster Minikube and the value here being as 80, right? So here we can see the value as 80. So this shows that Thanos is being able to, visualize our data now. What will happen with this is you're able to send your data as you can see. I'm just plugging in my like external tools in the config map as you can see. I'm just plugging my external tools, right? I'm just adding a endpoint for Nats. That's it. I'm not doing anything else. I'm just adding an endpoint for my Thanos. That's it. I'm not even changing Thanos or Nats to be added in my application. And I'm creating a pipeline for the metrics. That's all the change I'm doing. There is no external or manual configuration that I'm doing in my Kubernetes, right? So that's how easy it is to, collect your data via OpenTelemetry collector. There are different types of receivers in this is the contrib repo. The contrib repo is where the external tools other than the core exporters or receivers are being stored. And this is the collector repo where the core exporters and receivers are there. So the core exporters and receivers are, let's say, the OTLP receiver, right? So the OTLP receiver is the very native receiver in OpenTelemetry collector. This receives data in OTLP format, that is the OpenTelemetry protocol format, as well as it sends data in OTLP format, right? So you can very easily, contribute your own receiver or even exporter or even processor or extensions in this particular repo as you wish according to your business requirements. As I created a NATS receiver which was not present in this collector contrib repo. Yeah, that's it for the demo. And these are the reference. Yeah, this is the contrib repo and this is the docs. It has about 3.2K stars on GitHub with over like 300 contributors. And it's the second grossing CNCF project after Kubernetes. So yeah, that kind of shows how popular this project is in terms of collecting metrics. And yeah, that's it from my side. Thank you. If there are any questions, I can take them up.
Yeah. Uh, so if anyone has any questions, you can post them in the chat. Then we can ask from Tanisha. Uh, I don't see any questions yet. So feel free to ask any questions in further, and we will get it through Tanisha and get you answers. Uh, I think we can conclude. And thank you, Tanisha, uh, for your for the great session on open telemetry on Kubernetes. And now I need to reiterate our exciting news that KCD Sri Lanka 2023 will happen on 9th of September uh, at Trace Expert City, Colombo. So still we are in a pre-sale period. You can see the ticket price in at the screen. So anyone interested at networking and getting to know about Kubernetes and related uh, technologies, not only DevOps guys, that I need to emphasize that not this KCD Sri Lanka is not KCD Sri Lanka is not about only for the DevOps guys. Even Dev guys have things to learn from KCD Sri Lanka. That these are the speakers we have lined up for the KCD Sri Lanka, and they will speak about not only about Kubernetes that uh, and cloud native projects and dev related topics will be discussed in the KCD Sri Lanka. Uh, yeah, that's pretty much about that, and I think we can wrap up the today's session then. Thank you, Tanisha, and thanks all the attendees who made this event success. So let's meet on the next webinar. Thank you all.
Thank you.